Look up at the night sky tonight. Almost everything out there is lifeless. Burning rock, frozen dust, endless empty black. But here, a world where clouds gather, where it rains, where rivers run down to the sea and waves break against a shore. For one impossible second, it looks like home. Then you notice the sky is the wrong color. It glows a deep, sickly orange. The rain landing on your shoulders is not water, it is fuel. And the sea stretching out in front of you is cold enough to freeze you solid in a single breath. This is Titan. And the rain that fills its seas may be the strangest clue we have ever found in the hunt for life. For almost all of human history, Titan was a ghost. Even through our finest telescopes, it never became anything more than a fuzzy orange ball, its face buried under a permanent shroud of haze. We knew it was big, wider across than the planet Mercury. We knew it was the largest moon of Saturn, but everything beneath that orange veil was pure guesswork. Could a world this far from the sun truly have seas, and rivers, and rain, without a single drop of water? The first whisper of an answer arrived in 1979. A NASA probe called Pioneer 11 came racing past Saturn, and it could not see Titan's surface either. But it could taste the air, and what it tasted was eerily familiar. Titan was wrapped in a thick atmosphere of nitrogen. Stop and feel that for a moment. The air filling your lungs right now is mostly nitrogen too. No other moon in the entire solar system breathes anything like it. But there was a second ingredient in that air, and it made scientists lean in close. Methane. Rivers of it, in gas form. Methane is a hydrocarbon, the same family of molecules we pump as natural gas and burn as fuel. And hydrocarbons are not just fuel. They are the carbon-based scaffolding of life itself. So now Titan had a familiar sky, and that sky was raining the raw ingredients of biology. There was only one problem. We still could not see the ground. We would have to wait 25 long years. Then, in 2004, the Cassini spacecraft slid into orbit around Saturn, carrying radar and infrared eyes that did not care about orange smog. For the first time, we reached down through the haze and touched the world below, and the first thing Cassini told us was how merciless this place is. The atmosphere is 4 times denser than ours. Stand on that surface, and the air would press down on you with 50% more force than at sea level on Earth. And it is brutally cold. The surface sits at around minus 179 degrees Celsius. That is roughly minus 290 degrees Fahrenheit. So here is the problem. At a temperature like that, nothing should be able to flow at all. Water out here is not a liquid. It is stone. So what on Titan is filling those rivers? The answer hides in a temperature window so thin it feels almost absurd. Methane turns liquid at minus 182 degrees and boils away at minus 161, a band barely 20 degrees wide. And Titan's surface sits dead in the center of it. Out of every possible temperature in the cosmos, this one frozen moon landed on the exact sliver where methane can pool and flow and fall from the sky as rain, on a world where water is frozen hard as steel. Methane quietly took over, the job water does back home. But all of this was still a theory. We needed to go down and stand on it. So riding along with Cassini was a second machine, a small probe named Huygens, after the astronomer who first spotted Titan back in 1655. On the 14th of January, 2005, Huygens let go and fell into the haze. It became the first spacecraft in history to land on a world in the outer solar system. For 2.5 hours, it dropped through the orange murk, and as the clouds finally thinned, its cameras caught something that stole the breath of everyone watching. Valleys, river channels, branching and winding down the slopes, carved exactly the way running water carves the land on Earth. Then it touched down, and the photo it sent back looked almost ordinary, smooth, rounded pebbles scattered across a flat plain, tumbled and polished as if by a flowing stream. But there was no stream. Huygens had landed in a dried-up riverbed. The rivers were real, so where had all the liquid gone? The answer came from above. As Cassini circled, its radar swept the poles, and there they were. Vast, dark patches, smooth and flat. Exactly what a sea of standing liquid would look like from orbit. But scientists wanted certainty. It arrived in 2009 in one of the most haunting images ever taken of another world. Cassini caught a single point of sunlight glinting off a northern sea, sparkling back at the camera, the same way the sun flashes off a lake on a summer evening. That one glint was the proof. The seas were real, and they are monstrous. The largest is called Kraken Mare, and it is bigger than all of North America's Great Lakes put together, in places. The radar found it more than 100 meters deep. Picture it. A sea the size of a continent, filled not with water, but with liquid natural gas, sitting black and silent in the cold and the dark. But Titan was hiding one last riddle, high in that orange sky. Sunlight is forever tearing the methane apart, breaking it down into the haze itself. A slow rain of soot. Do the math. And Titan should have burned through every trace of its atmospheric methane in about 50 million years. A heartbeat against the age of the solar system. And yet the methane is still here. Something is refilling the tank. The leading suspect is volcanoes, but not the kind you know. Titan is far too cold for molten rock. Instead, scientists think it erupts cold, spewing a slush of water and ammonia up from deep inside. We have never caught one in the act, and that single uncertainty leaves a door cracked open in the dark. And it explains why Huygens landed on dry ground. Out here, the sun is too weak to lift much vapor, so the clouds hoard their methane for ages before they finally break. The result is a climate of terrible patience, droughts that drag on for centuries, then shatter into sudden, drowning downpours that flash flood across the whole moon. We did not land on a lifeless world. We landed in the dry season. The rivers were waiting. We simply missed the rain. So this is what Titan turned out to be. The only other world we have ever found with seas like our own. A place with rain, and rivers, and shorelines, and weather. A living, breathing cycle, running on fuel instead of water. But remember that door we left cracked open? The question of where all that methane keeps coming from. Because on Earth, most of the methane in the air is made by living things, by bacteria, by life, breathing it out into the sky. On Titan, we think the source is geology. We think we are not sure, and there is more waiting beneath our feet, because far below that icy crust, scientists believe Titan hides a second secret, a buried ocean of liquid water, dark and deep and silent. Soon, we are going back. A nuclear-powered drone called Dragonfly will fly across Titan's skies in the 2030s, landing on those alien shores to taste the chemistry for itself. And when it does, the oldest question of all will be waiting there in the cold. Wherever there is a sea and a shore and a steady rain, the question always returns. Could something be moving out there? In the dark methane tides, we still do not know, but for the first time in history, we are going there to ask.